Most welcome to my YouTube channel. So in this lecture I will discuss the polar form of CR equations. So in Cartesian form, if A equal to u plus iv is differentiable at z0 or at a point z equal to x plus iy, then CR equation will be satisfied, that is ux equal to vy and uy equal to minus dx at this point z equal to x plus I. So this is CR equations in Cartesian form, and now we discuss polar form of CR equations. So whenever we talk about CR equation, that means this function f is differentiable is given. So first we assume that f z is u r comma theta plus I v r comma theta, that is in polar form, is differentiable at a point z. ठीक है, at a point. So z का polar form will be r e to the power I theta. So if this is z, that is x plus iy, so this will be x, this will be y, this will be theta. So x equal to r cos theta, y equal to r sin theta. So from this we get z equal to r into cos plus I sin theta, that is r into e to the power I theta. So this is the connection between polar and Cartesian coordinate of a complex plane. So this is given that fz is differentiable at a point z, which is given this. So this given means this limit z plus h minus f of z divided by h is exist. This means the limit as h tends to 0 of this function is exist. Okay. So this is nothing but f dash z. So now this is r and this is z. So we choose point near to this z along this radial, that is on this r. So r will be r plus del r. Therefore the nearby points of z along radial direction, that is if this is r, so these points and these points are the nearby points of z along radial direction, that is this is radius. So if we draw a circle, so this will be like that, this is radius. So in this radial direction we choose nearby points, so that will be the nearby points of z along radial direction may be written as z plus h, that is r plus del r into e to the power I theta. So we just sum other points near the z. So from then we get h equal to this z plus h minus z, that is this minus this. So we get del this minus this, we get del r into e to the power I theta. Okay. So now we find f dash z. Now we put this h, z plus h for z. This is function value at z and this is function value at z plus h. So therefore u as this function f was u r theta plus I d r theta at the point z. Okay. So now f of z plus h, so r will be this. So therefore u r written as r plus del r comma theta plus I d r plus del r comma theta. So now we put this f of z plus h and h in this equation. Okay. So let us write. So f of z plus h minus f of z divided by h, this can be written as f of z plus h by h minus f of z by h. I am calculating in such a way that you all are understand the calculation. Okay. So first we write this f of z means u r plus del r comma theta plus I d r plus del r comma theta divided by h means del r into e to the power I theta, and this is minus f of z, that is u r comma theta plus I d r comma theta divided by h, that is del r e to the power I theta. So now we collect u and v. So we can write from here u r plus del r comma theta minus u r comma theta divided by del r, and we can write here as this is 1 by e to the power I theta. Okay. Similarly, for this v term, so we get common I, so this will be I by e to the power I theta, and this will be v r plus del r comma theta minus v r comma theta divided by del r, as h equal to del r e to the power I theta. So h tends to 0 implies that del r tends to 0. So whenever we find f dash z, this limit h tends to 0. Therefore, if we have to take del r tends to 0. So therefore, allowing del r tends to 0 as del r not equal to 0, we get from this, that is this limit will be f dash z, and this is nothing but this. So therefore, this will be 1 by e to the power I theta. So this will be, so you can assume that u r plus h theta minus u r comma theta, that is r theta at r theta. This is the differentiation, partial differentiation with respect to r. So we can write u r. Okay, this is r comma theta. So similarly, this will be I by e to the power I theta, and this will be v r function of r theta. So we can write simply 1 by e to the power I theta. So this will be u r plus I v r. Okay, so this is the equation number 1. Okay, so write that f dash z equal to this is a equation number 1. We write the equation number 1 here, that is f dash z equal to 1 by e to the power I theta u r plus I v r. Okay, now we choose nearby points of z along the circular path through the point z. That is, if this is z, okay, z is r e to the power I theta. So this is r. So first we choose along the radial direction in this line, point in this line. So now we discuss. So this is theta. So circular path means for this z point, the angle, that is argument, is theta. So therefore, if we choose the points this that is on this circular line, that is on this circle whose radius is r, so then for this point, the nearby point z plus h, so can be written as z plus h equal to r into e to the power I. Theta will be theta plus del theta. So this is the difference. So we choose circular path. So if we choose nearby points through the point z, so this line is through the point z. So if we choose these points on this line, so for that point r will be same, that is radius will be same, but theta will be changed, that is theta will be theta plus del theta for this z plus h. So that's why we call it, we choose nearby points of z along the circular path through the point z. So now we choose z plus h this. So therefore h equal to z plus h minus z, that is this minus, that is r e to the power I theta, and this will be e to the power I del theta minus r e to the power I theta. So therefore it will be r e to the power I theta into e to the power I del theta minus 1. This is the h. Okay. So whenever we choose nearby points of z along circular path, then z plus h becomes like this, as here r will be unchanged and the circular angle, that is theta, will be changed. So as we increase this, change the position of this point z, so theta will be changed to theta plus del theta. Therefore we get h equal to this. So this we have to find this. So for this point, that is f plus z plus f of z plus h now will be u r, and theta will be theta plus del theta plus I v r comma theta plus del theta. Okay, and f of z is nothing but u of r theta plus I v of r theta. Now we put these all values in this equation. So h is, so we write h is e to the r e to the power I theta e to the power I del theta minus 1. In the similar way, we put first this, that is u r comma theta plus del theta plus I into v r comma theta plus del theta divided by h is r e to the power I theta, and this is extra term I e to the power I del theta minus 1, and this will be minus fz, that is u r theta minus plus iv r theta divided by this r e to the power I theta into e to the power I del theta minus 1. So you have to adjust in such a way that this will be the partial derivative with respect to theta, as u r comma theta plus del theta, and here u r theta. So if we write this minus this and under this del theta, so we get u theta, that is partial derivative of u with respect to theta. So we have to adjust this. So write u r comma theta plus del theta minus u r comma theta divided by this whole term, that is r e to the power I theta into e to the power I del theta minus 1, and here this is I v r comma theta plus del theta minus v r comma theta divided by r e to the power I theta into e to the power I del theta minus 1. So up to this is same, but now where is the problem? So we have to write in such a way that this will be u r comma theta plus del theta minus u r comma theta, and under this is del theta, and here the extra term is r. So we write here r e to the power I theta, and here e to the power I del theta minus 1. So we have to use one limit. So for that we have to multiply I del theta. So this I del theta, and here this I del theta is cancel out. So we have write this in this form, that is I del theta by this. So these are here, but this will write for the differentiation of u with respect to theta. So this I you can write here. So therefore this is the term which will give you u theta, okay, partial derivative of u with respect to theta. So therefore from this also we get this is plus, that is I. So under, if we common this term, that is I r theta, so therefore so you get I divided by r e to the power I theta, and here you write this v r comma theta plus del theta minus v r theta divided by I del theta into this I del theta divided by e to the power I del theta minus 1. So this I will come here, okay. So this I is this, but for this we take here I and here del theta. So this is the form. So therefore we can write here. So simply you write this and total common. So this time coming here. So this will be I and this will common. So from this you can write. So this is, and this is plus I into v r comma theta plus del theta minus v r theta divided by del theta, and this second bracket के बाद I del theta divided by e to the power I del theta minus 1, ठीक है. So this ultimately you will get this. So from this you will get u theta, from this get you will v theta. This is I, and what about this? So we will discuss that. So this is, as h tends to 0, so we take r not equal to 0. So this del theta tends to 0. So if we allowing del theta tends to 0, so f of z plus h minus f of z divided by h limit h tends to 0, this will be, that is same as allowing del theta tends to 0, and therefore we get f dash x f dash z equal to, this is 1 by I e to the power I theta, and from this you will get u theta, and from this plus I v theta. and this will be 1 as theta tends to 0. That is del theta tends to 0, I del theta divided by e to the power I del theta minus 1. How? So just you put I del theta equal to something like the x, you put x, therefore this can be written as limit x tends to 0. This will be x by e to the power x minus 1. So as x tends to 0, 0, and this is e to the power 0 minus 1, that is 1 minus 1. So this will be 0 by 0 form. So just L'Hospital rule, apply L'Hospital rule, and this will get x tends to 0. This will equal to the derivative of x, that is 1, and this will equal to the derivative of this function, that is e to the power x. Now if you put x tends to 0, so you get from this 1 by 1, that is 1. So that's why this total term will be equal to 1 when we take del theta tends to 0. So therefore this is 2. So from first equation, so this line is very important. By calculating this, we get this from this u theta, from this v theta. This is fz 1 by I theta, that is this equation was 1 by r I r e to the power I theta. This will be this. So this I del theta divided by e to the power I del theta minus 1. So first term should be this. So this will be I r this. Okay. So I made a mistake. So this will be this. So this equation 4 and 1 is 1 by e to the power I theta, and this is ur plus I dr. So from this we get, if we multiply I both sides, so this will be I divided by minus 1. So then from this we get r e to the power I theta. So this will be I cancel out v theta, and this will be minus 1 I minus 1, that is minus I u theta. Okay. So this will be this. So both are f dash z. So comparing these two, we get, so 1 by e to the power I theta, 1 by e to the power I theta will be cancelled out. So from this we get u r equal to, this is v theta by r, and from this v r equal to minus u theta divided by r. So this is the CR equation in polar form. So how you remember? Let us talk about that. So you can note, in Cartesian form, f equal to u, that is x plus y plus I d x plus x comma y. So this is ux, this is uy. Okay. So this will equal to vy, and this will equal to dx but minus. So this is the Cartesian CR equation in Cartesian coordinate. And if this f equal to u r comma theta plus I v r comma theta, that is in polar form. So just compare, this is x and this is y. So therefore you get u r and u theta as we take u x u y. So therefore this is equal to vy, that is v here theta, and here u theta, that is uy equal to minus vx, that is minus vx means r. But whenever you write derivative with respect to theta, you multiply that side by 1 by r. So you get the polar form. You can compare with this. How you can remember this form? So whenever, so now we discuss Laplace equation in polar form. In Cartesian, Laplace equation for u as a function of xy is del 2u del x square plus del 2u del y square equal to 0. But whenever u is in polar form, so this del 2u x is del r square plus del 2u del theta square. So this equal to 0. You are thinking this should be, but this is wrong. So in the polar form, what will be the form of Laplace equation? We will discuss that. Okay. So for that, we take first equation, ur, first equation of CR equation, that is ur equal to v theta by r. So therefore v theta equal to r into ur. So just derivative with respect to r v theta, that is whenever we derivative r, so ur is constant. We apply the derivative of a multiple function, that is xy, ddx of u into v. U and v are both a function of x. So in this case, so derivative r, ur as it is, plus r when derivative ur, so this becomes urr, that is double derivative. So this is the, okay. So this is first equation. And whenever we take the second equation, that is Vr equal to minus u theta divided by r. So we derivative with respect to theta this. So we get whenever we derivative with respect to theta, so r is a constant and u theta become u double theta. That is double derivative with respect to theta. So from this is v theta first r, that is v theta r, and this is v r first theta. So we derivative first with respect to r and then theta, and here this means we derivative v with respect to theta first and r second. So whenever second derivative of a function exists or it is continuous, so therefore these two will be equal. So for the CR equation, so this f should be analytic if this partial derivative are continuous. So from this, these two will be equal. Equal means, so this right hand side be equal. So therefore we can write, that is from equation 1 and equation 2, right hand side will be equal. That is ur plus r urr equal to minus 1 by r u theta theta. So from this we can write r into urr plus ur plus 1 by r u theta theta equal to 0. Okay, so if we divided each term on both sides by r, we get divided by r, so this will cancel out, this divided by r, and this will be square and this will be 0. So this is the Laplace equation in polar form. This is the Laplace equation in polar form, polar coordinate. Okay, so this is the Laplace equation urr plus 1 by r u1 plus 1 by r square u theta theta. This was the very important problem. So if you like it, please subscribe, share with your friends, and keep learning. So thank you very much.